Hello everyone. Today we'll be understanding the chapter 4th of maths, that is linear inequalities. And if you get to understand this very easy chapter, you'll be very easily scoring 4 to 5 marks from this chapter in your board exams or even in your home exams. So let's begin understanding this chapter. So this chapter majorly deals with inequalities. The inequality is basically dependent on four signs, which is greater than, less than, greater than equals to, or less than equals to. It deals with just majorly these four signs. So what does greater than mean? It means that if a value is greater than or less than, it is basically used to show relation. And now you may ask, what is the work of these two? Don't they show relations? Yes, they do show relations, but there is a very small or minor difference which you can notice, which is here is also equal to sign with them. So now what it indicates is that if I have written that x is, maybe equal to 1, what you can say that x is just equal to 1. But now if I give you another example, for example, x is smaller than equals to 5, let's say, and x belongs to n. Now what will you say? So first we need to understand what is the meaning of n here. N here represents natural numbers. So what are natural numbers? Natural numbers are those numbers which start from 1 to and so on. So same goes for other types of numbers, but it's just an example, so I have to explain you for that. So now, what will be this value? If you just make a solution set and you have to take only and only natural numbers, no integers, that means no negative numbers, just pure positive numbers, that too from natural numbers. So what will be your answer? Your answer is going to be 1, 2, 3, 4. And you will also include this 5. So it will be 5 also. But now, on the contrary, if I give you another example, that x is just smaller than 5. So what will be the solution set? And also x belongs to n. So everything is same. Everything is similar to the above example. But what is different is that it does not have this equals to sign here. So can you tell me what will be the solution set? Just pause the video right now and write the solution set anywhere. This will help you to check the answer when I'll be telling this. I hope you have written your answer. So now the solution set for this particular inequality will be 1, 2, 3, 4. That's it, not 5. Why not 5? Because it is not equal to 5. Here it was equal to 5. So I hope you got to understand the difference between these types of inequalities. So now we'll move on to the next major part of this chapter, because I have seen no one is telling all these things in their one shots respectively. So I thought, why not? I'll tell it in my one shot. So now in this, you can see that there are, if for example, I have given this x belongs to n, which means x belongs to whole number. So if I say x belongs to z, x belongs to w, or x belongs to, you can say, n, and x belongs to r. So these are the only major types of four situations that you will come across while solving questions. And x will belong only to these things. So if you are worried or you're confused about what is this symbol, this symbol particularly is the symbol of belongs to. So that is the thing. And now let me tell you, z here represents integers. W represents what? W represents whole numbers. Okay, N represents natural numbers, and R represents real numbers. So let me explain to you one by one what all are these. Let me just give you a very short and a quick recap. Integers are both positive number and negative number. That means you can go on from -1 to -2, -3, 1, 0, 2, and so on. So whole numbers start from 0. They start from 0, as you can see, and they go on and on just like normal numbers, 0, 1, 2, 3, and so on. For natural numbers, they start from 1 and they go on just like 1, 2, 3, 4, and so on. Now coming to real numbers, this is quite really important. So the real number includes rational and irrational numbers. Basically, it means that it includes all kinds of numbers. So if I take a very lame example, it would be that here's a number line. I've just taken out a segment from number line. Here lies 1, here lies 2. And in between 1 and 2 lies infinitely many numbers. So all of these numbers which will come between 1 and 2 are rational numbers. Between 1 and 2, what can come? It will be 1.2, 1.1, many other numbers. It will be, they can be fractions also, they can be decimals and more such kind of stuff. So we refer it to as real numbers. Okay, so one more thing, let's talk about the representation of various numbers on the number line. So if you are said to just represent this example which I gave you just now, so you have to represent it on a number line. So first of all, draw a very neat number line because I'm free handly drawing it, so it could be a little wrong, sorry. Well, we'll make this from 0 here. There also will be -1, but I'm not drawing that whole thing because I need the positive parts. 1, 2, 3, 4, 5. So now in this case, n belongs to n, which means natural numbers. So we'll only have to just circle 1, 2, 3, 4, and 5. Same goes for integers or any other numbers which you can circle. Fine, that's it. And now, if you're given to just color in real numbers, then what will you do? So suppose it was that you have to color all the natural numbers and x belongs to r. This time x belongs to r. The example is same. X is smaller than equals to 5, but this time x belongs to r. So what will you do? I'll just make one more number line real quick. 1, 2, 3, 4, 5. Okay. Now, what will you do? You can see that the starting point of this example is 1 because the first natural number that comes in the category is 1. So you can just make a full dot over here and you can just make a full dot here and you will darken the whole number line in between. And it will mean, by darkening, you want to signify that all the numbers from 1 to 5, between 1 to 5 are rational numbers and that will be the value of x. Is it okay with that? I think so. And let me just clear that to you also. If the condition would be something like this, then how will you represent it on the number line? If x belongs to r this time, what will you do then? Let's make one more cute little number line here. Fine. We'll take it from -1, 0, 1, 2, 3, 4, and 5. So in it, it says that x is less than r. Sorry, x is less than 5. So what will you do? Which means that x is less than all the quantities which are less than 5. So what will you do? You will just draw an empty circle over 5 because 5 is not included because x is not equals to 5. So 5 is not included. You'll just draw a hollow circle and you will color the parts from here to here because our real numbers can be from infinity to. So I hope you have understand this topic. Let's move on to the rules of solving the inequation. So I think you have already known these rules. In equations, it is the same as well as in inequations. So if there is a positive number and there is an equals to, what do you do when this number goes from the left hand side to the right hand side? What do you do? It becomes a negative number, right? For example, if there is a negative number, it goes to the right hand side, it becomes a positive number, isn't it? So same happens in inequalities. What happens if there is, suppose, any x number and there is an inequality which says greater than equals to or anything like that, and x is of negative, maybe let's say it's negative. If it will go towards the right hand side, it will turn positive, isn't it? So that is the thing. And if we have a positive number here, for example, let's take some other number, let's take 5. If it goes towards the right hand side, it will turn into -5. Okay, I hope you're understanding all of these questions and stuff because it is the same as in equations. So now let's move on to another thing. So suppose if there is a number and you are dividing that number by a positive one, so then it will be positive, right? You're doing it on both sides. There's no need for the number to be same. It's just I've taken a variable. You can just take any other number in your case. Fine. So if we do it here too, for example, if I divide 5 by 4, it will be 5 by 4 on both sides. So you need to remember this. Whatever you're doing, you have to do on both the sides of the equation. So that is it. And same goes for multiplication. If you are dividing that number by a positive number, you have to divide it here also. So same goes for here. If you're dividing 5 into 4, let's say, you can even reverse the sign, whatever. I've taken another example, or otherwise you might be thinking, oh, when it is greater than this, only you do. No, the sign does not matter. What matters is the numbers, what we are dealing with. So it has to be 5 into 4. The sign does not change in any case. Fine. But now comes the important parts. Now you need to pay attention here. If what do we do if we have a number, for example x, and we divide it by a negative number? We also have a negative number here and we divide it by 1. So if the sign was earlier like this, after this division, it will change into the opposite one. Did you understand this? So let's understand this with the help of an example. If you are here, suppose let's say you have a pizza. We have 2 pizzas. And now I divide it into 4 slices. And this one I divided into 6 slices. Is that okay? 1, 2, 3, 4, 5, 6. Yes, it's 6 slices. So now I've divided these pizzas. So earlier, what was there? 4, 6. Which one was greater? Absolutely yes, 6 was greater. But now if I say I have this one part and I have also this one part. So which one would you prefer to take? The bigger one, yes? Now I say 1 upon 4 or 1 upon 6. Which one will be bigger? The sixth 1 upon 6 slice of a pizza or the 1 upon 4th slice of a pizza? Yes, of course, 1 upon 4th. So even if you take the reciprocal of a number, the sign of inequality changes. I hope you understood that thing. And now, same goes for multiplication. If you multiply a number, for example, I've taken x. If you multiply it by a negative number, suppose the sign of inequality was earlier like this, and you multiply it with a negative number on both the sides. So after multiplication, what happens? The sign of inequality reverses and it will change into the opposite sign. So that is it. That were all the rules which you need to keep in mind. So this is quite important. If you divide, if you multiply, if you divide, or if you reciprocal by a number, in these cases a negative number, and even if you normally reciprocal a number or something like that, the sign of inequality changes. Fine, you need to keep this in mind. It's very very important. Two star important, it's that important, so that was the whole chapter of linear inequations. You can see it once more. You need to keep this in mind too, because if the question comes x belongs to z, now you might not sit in the examination hall thinking that, oh my god, what is x, what represents x, or something like that. I've told you here right now it represents integer. I have told you to color the number line and stuff. And this sign of inequality changes in which conditions? If you multiply or divide by a negative number, or if you do the reciprocal of a number on both the sides, the sign of inequality automatically changes. You need to keep that in mind. Now we can even practice one or two questions to just boost up your confidence.